We shall be looking at the logarithms of numbers, and in this class we shall be making use of the logarithm table. So here on our introduction we have to be considered in this case for this topic is the logarithm to base 10. Yes, since the 4-figure table is a distribution of numbers in base 10 only. So the 4-figure table makes use of just base 10 only. Other bases are not required and the use of the 4-figure table. And for this topic, basically logarithm to base 10, we shall be looking at two major points here, which is the characteristics and the mantissa. Now, the integral or whole number part of a logarithm is called the characteristics. Yes, so if you have a whole number, or if you have a decimal number, the whole number part is called the characteristics, and while the decimal part is called the mantissa. So let's look at some examples here of what we're talking about. Now, for example, let's consider the table below. We have some numbers here. We have 10, we have 100, we have 346, 654.91, and so on, up to the last number here, 7465.86657. Now, as we can see, for the first number 10 is having no decimal. Yes, so therefore the mantissa, it has no mantissa. And for the characteristics, it's 1. Yes, same applies to 100. 100 has no decimal part, therefore the mantissa is none, and the characteristics is just 2. Now let's see how this we're gotten. It's actually simple to understand. And for the first number, we have 10. Now, watch this. 10. It has no decimal, but how many digits makes up 10? So, it implies that the 10 has just 2 digits. So, 2 digits. And in this case, I'll just do a minus 1. That is, I'll just do 2 minus 1. It is equals to 1. So, therefore, 10 has just 1 as the characteristics. That is why it's in red there. Now for 100 is what? 100 has 3 digits. 1, 0, 0. It has no decimal, so it won't have any mantissa. Now it has 3 digits. 1, 0, 0. So I'll write this way. 3 digits. Yes, that is, I'll just do a 3 minus 1, which is equals to 2, and therefore 100 has 2 as the characteristics. Now for 346 in the same way, 346 has just 3 digits, that is 3, that is 3, 4, 6. Yes, this number also has 3 digits. It has 3 digits. So I'll just do this. I'll do a 3 minus 1 to give us just 2. So therefore 346 has 2 as the characteristics. Now let's look at 654. 654.91, 654. Now looking at 654.91 here. Now exactly, this number has a decimal place. 654.91 has a decimal place, and it has just 91 on the decimal side. Yes, it has 91 on the decimal side. So it implies that the mantisser here, is just 0.91. Yes. But what about the characteristics? Now for the characteristics, it's just this. We have 654 there as the whole number. The whole number here is 654. So we have 654, which implies that it's having a 3 digits on the whole number. So do the same thing by doing a -1 always. I'll have 3 minus 1, which is equals to 2. So, and therefore 2 happens to be the characteristics. Yes. Why 0.91 seems to be the mantisser. Now let's look at the next one. 34.345. 34.345. Now, firstly enough, you can see here that this is the decimal part only, and the decimal part happens to be our mantisser. That is, the mantisser here is just 0.345. That is the mantisser. But what about the characteristics? Now, as for the characteristics, as you can see, we're having 34 as the whole number. We're having 34 as the whole number. Yes, we're having 34 as the whole number. So, 34 is the whole number. We write it out, or have 34. Now, which implies the whole number is having 2 digits. 2 digits. Yes, so that is, I'll just do -1, 2 minus 1, which gives us 1. And so the characteristics for 34.345 is 1. And as the one we solved before, and as you can see the mantisser as well, is 7.345. Also for the former one we did, the number is 654.91, but the characteristics is actually 2, and why the mantisser is just 0.91. And now lastly, for the last number there, we have 7465. Let's write it down here. So the last number is 7465.867. Now, as we now know that the mantisser is just the decimal part only, Let's see a different color. Yes, the decimal part is just this. So I can say that the mantisser is equals to 0.86657. Now what about the characteristics? It's just this whole number here. Yes, this whole number here. So which is 7465, which implies 4 digits. And that is, I'll do, since it has 4 digits, I'll do 4 minus 1, which gives us 3. And therefore, our characteristics for 7465 0.86657 is just 3, just as we have on the table here. Why the multiplier is 0.86657, just as we earlier saw. Now we are on the next slide. The logarithm of numbers greater than 1. Now we could have as many as possible, but we have just 6 here. So we have 176, 2784, 1.374, 5.59, and so on. Now, as we have learned initially how to convert numbers to standard form. As you can see, all numbers here are written in standard form. Yes, so also notice that the powers of 10 in every case is positive. From letter A to F, you can see that the powers of 10 are all positive. Hence, such numbers are referred to numbers that are greater than 1. Okay? So let's look at the next slide here. Now slide, we have the next one. Logarithm of numbers less than 1. Now this is very obvious, of which you can differentiate from the first we just had. So the log of numbers less than 1. Now from A to F, you can see you have 0.00176, 0.84, 0.000074, and so on. So, and in standard form, as you can see, they are all written, and as you've learned initially how to write such numbers in standard form. Now, you could notice that all numbers in this case, in the powers of 10, are all negative. The powers of 10 for these numbers are all negative, telling you that these numbers are less than 1. Now you could compare with the former slide. As you could see, for these ones, you could see that the difference between these two. Now, I gave a summary note here. That from the previous slide, which we have this here, notice that from letter A to F, they all begin with 0 points. They all have 0 point, 0 point, 0 point, 0 point. Yes. So, whenever the number given to us to work with begins with 0 point something, now it's considered to be less than 1. As you could see, these ones, they all begin with 0 point something, 0 0.0, 0 0.84, and so on. So whenever it begins with 0 point something, you should know that the number is less than 1. Now also, but if it doesn't begin from 0 point something, it is considered to be greater than 1. If it doesn't begin with 0 point something, it is considered to be greater than 1. Just as we have on the previous slide here, these numbers A to F, they do not begin from 0 point. As you can see, they do not. No one began with 0 point something. Hence, they are greater than 1. Hence, they are greater than 1. Now, here is just a preview of how our 4-figure table could look like. So as you can see it, this is just how it looks like. It begins from 10 and ends in 99, or as 99. It begins from 10 and ends at 99. So this is how it looks like, beginning from 10. Although I just snapped, or I had to crop just the first page. So it begins from 10 and ends in 99. So also, as we have in our anti-log table, also begins from 0.00 up to where it ends. Okay, let's look at the next slide. We're finding the logarithms of these two living numbers. 1 to 8, 1 to 9, sorry. So now let's start with the first one. We are asked to find the logarithm of 3345. 3345. So how do we find this? Now, first of all, let's write it down here. 3345. The log of 3345. Now, this is equals to, first of all, I need to determine the characteristics of this number. Let's determine the characteristics. I think we've done how to find it. Now, to find a number's characteristics, first of all, determine the number of digits in the whole number. For this number 3345, the whole number is just 3345. And how many digits are in 3345? It's just 1, 2, 3, 4. Yes, 3345 just has only 4 digits. I mean this. It has 1 digit. Okay. It has 1 digit. It has 2. It has 3 and 4. So 3345 has just 4 digits in the whole number. Therefore, I'll do a minus 1. Yes, 4 minus 1. So I'll have 3 point something. And now, that is for my characteristics. Now, you can see the log table here. Log table begins from 10. So, let's now find 33. Yes, let's now find 33. Yes, because I cannot say let's find 3 and the log. We don't have log. We don't have 3 in the log table. 3 does not begin here. So, what begins the log table is from 10 and it ends at 99. So, I will say let's find 33. Yes, under 4. So look for 33 under 4. So I think this should be 33 here. Yes, and look for the value under 4. 33 is under 0, this under 1, under 2, under 3. Yes, this 33 under 4 is this here. Yes, you can see under 4 here, I mean. So, trace it down here is 5237. So, looking at it, is 5237. We have, let's do something here, is 5237. Now, let's now check the difference of what? Difference of what? So, this is, as we have it, is 33 under 4 here. This is 33 under 4. Now, the difference of 5 is our difference column. Difference of 5, trace it under here. So, difference of 5 should be somewhere here. Okay, difference of 5 is 6. Yes. So, 33 under 4, at base 33 under 4 is 4. So, I traced it down here. Yes, and then the difference of 5, this is the difference of 5, so trace it also to that same row. Yes, so we have 6 there. So let's now add it. And I add 6, so we have plus 7 plus 6 is 13, 3 carry 1, 1 plus 3 is 4, then 2 and 5. So our answer is now finally 5, 2, 4, 3. Before I solve the next question, let's look at this question here. We are asked to find the logarithm of 2678. 2678. Now, it's still the same process for 2678. Now, check how many digits does 2678 has. How many digits? It has 1. It has 1 here. It has 2. It has 3. And it has 4. So, this number 2678 has 4 digits as the whole number. So, and as we know, to get the characteristics, you just do a minus 1. So since it has 4 digits, just do a minus 1. So I'll have 4 minus 1 is 3 points. Yes. Now the next thing you should do is to now check on the table, your log table. We'll begin from 26. Since we don't have 2 on this column here, log value begins from 10. So I cannot say look for 2 under 6. No, since we don't have to, let's begin from 26. So I'll say look for 26 under 7, difference of 8. So there is 26 here. So this is 26 here, as you can see. As you can see, we have 26 here. Yes. Now trace this value under 7. Trace this value under 7. So this 26 under 0, is under 1, under 2, under 3, under 4, under 5, under 6, under, yes, this is 7. So, or 26 under the 7 here. Yes, 26 under 7 is 4265. So it's 4265. Write this on here. 4265. Because we still have another number to do it. So 26 under 7 is 4265. Now get it at difference of 8. So go to the difference table and column. Difference of 8, this is difference of 1, difference of 2, difference of 3, 4, 5, 6, 7, 8. Yes. So at difference of 8 is 13. I mean this difference of 8 here. Yes, so trace it down to 26. So it's going to give you 13. You have 13. So when you add these values together, 5 plus 3, 8, 6 plus 1 is 7, I have 2 and 4. Finally, my answer becomes 4278. And that is why the logarithm of 2678 is just 3.4278. So we have the second question here. Find the logarithm of 3, 3, 4, and 5. So we have it here. I'll be careful here. The previous ones we solved, we are not having decimals, but here we are having decimals, and in every decimal there must be a whole number. So focus on the whole number only. Focus on the whole number only. So the whole number here is just 334, as you can see. Now, how many digits are there in 334? It has 1, it has 2, it has 3. Yes, the whole number 334 has just 3 digits. So do a minus 1, and I will have 3 digits minus 1. That should be 2. So I'll have 2 point something. Now the same thing, go to your logarithm table. Do the same thing. We don't have 3, so I will have to use the first 2 digits, that is 33. So look for the 3 under 4 difference 5 again. So look for 33 under 4, which we've had it before. So this is 33 under 4. This under 4, which is here. Then difference of 5. Difference of 5 is somewhere here. Yes. So let's now add its values. So first of all, we got the log of 33 under 4, which gives us 5237. So 5237. Now difference of 5 gave us 6. So I will have it to be 7 plus 6 is 13. I will have 4 here, 2 and 5. So my answer becomes 5, 2, 4, 3. Yes. Now let's look at the third question. The third question. 33.45. Let us find the logarithm of 33.45. Now to solve this one, it's just the same process. Just the same process. So as we have here, the log value of 33.45 is equal to what? Now, just as we've done before, focus on the whole number. Since this is a decimal number, focus on the whole number. The whole number here is just 33. The whole number here is just 33. Yes, that is the whole number there. Now, this whole number has how many digits? It has just 1, 2. Yes, it has just 2 digits. So to now get my characteristics, I will just do minus 1. So 2 digits minus 1 is just 1, and then point. We've done this before, so let's look for the same thing. Look for 33 under 4 difference 5, which we've had before. So the one before, that is 33 under 4 is 5, 2, 3, 7. Yes, difference of 5 is 6. So we've had it before, so when I add, I will have 3, 4, 2, 5. So our answer is 5, 2, 4, 3. So finally here, the answer is 1.5243 as our answer. So let's look at the next question. Now we are on the fourth question. The fourth question says find the logarithm of 3.345. 3.345. Now, which we have here, this also is a decimal number, and as we know, to get our characteristics, we must focus on the whole number part. So the whole number here is just 3 only. Yes, 3 only. Now, how many digits are in this whole number? We have just only 1 digit here. Now, to get our characteristics, I will do a minus 1. So 1 digit minus 1, we have 0. Because 1 minus 1 is 0. So we have 0 points. We do the same thing. We do 33. Since we don't have 3 under the logarithm table, so we do 33 under 4 difference 5. We've done this several times. So our answer will still give us 5. We still have our answer to be 5, 2, 4, 3. So this is our answer for log 3.345. So let's look at question 5. Question 5 says find the logarithm of 10. So how do we find the log of 10? Now first of all, as you can see that 10 here is just a whole number. Yes, 10 is just a whole number. So it's having just 1 and 0 only as whole number. Now, how many digits does 10 have here? 10 has just 1 digit and 2 digits. Yes, 1 and 0. Yes, 10 has 2 digits. So, to get my characteristics, I will just do a minus 1. So, the 2 digits minus 1 is 2. Since, sorry, the 2 digits minus 1 is 1. Since 2 minus 1 is 1, so I have 1 point. Now, we don't have log 1 on the table, no, so I'll just look at log 10 only. Since there are no other digits there, so we only have 1 and 0, so I'll just say look for log 10. Log 10 at 0, log 10 at 0 is just 0, 0, 0, 0. So 0, 0, 0, 0. And therefore, the logarithm of 10 is just 1.0000. It's the same thing as saying 1. And that's the answer. Now let's look at the sixth question, the logarithm of 1000. Log of 1000. Now as you can see here, this is 1000. So 1000, it has no decimal, as you can see. So it's only made up of whole numbers. So it only has whole numbers, and check the whole number here only. Now for 1000 has how many digits in its whole number? It has 1, that is the first digit. It has 0, the second digit. It has 0 again, the third digit, and it has 0 again, that is the fourth digit. So 1000 has 4 digits. 1000 is made up of 4 digits. 1, 0, 0, 0. Now always do a minus 1 to get your characteristics. Always do a minus 1. So 4 digits minus 1 gives us 3. Yes. So we have 3 point something. So as you can see now, let's now get the log value of this. We don't have 1000 in the table, so I cannot just say look for log 1000 here. No. I can't just say let's look for log 100 on the table. No. So what we can only use from here is just to use log 10. So we will say look for log 10 and under 0. So no other digit there to make 0. So we're gonna do log 10 under 0, which is still, as you can see here, log 10 under 0. This log of 10 here, and then under 0 is just 0, 0, 0, 0. So just 0, 0, 0, 0. So that's it. And therefore 3.0000 is just the same thing as saying that log 1000 is just equal to 3. That's the answer. So let's look at the next question here. Log of 1300. So the log of 1300. Now the same thing, determine, this is a whole number, good. So how many digits are in this whole number? 1300 has 1300. That is 4 digits. So 4 digits, just do a minus 1, and I will have 3 points something here. So I have 3 points. Now we don't have 1300 on the table. We don't have 6. We don't even have 130. So I can't use 130. So the only closest number to make use of is 13 from that same number. So let's look for log 13 under just zeros. So log 13 under 0 is log 13 here. Log 13 under 0 is 1139. Log 13 under 0 is just 1139. And that happens to be our answer for log 1300. So let's try a different question. While you try this on your own later, try number 8 and 9 on your own later. So let's try a different number. Let me say I have you ask to find log 272.1. So how do we find this? This is very easy. So it is equals to, now this is a decimal number, as you can see. It is a decimal number. So and the decimal number would always have a whole number part and a decimal part. So for this number here, what is the whole number here? The whole number is just 272. And 272 has how many digits? 272 has just 3 digits, 2, 7, and 2. Yes, so 3 digits. Do a minus 1. Now have 3 minus 1 is 2 points. Now we don't have 272, and we don't have 272 on the log table. So what we can just do here is to use 227. Yes, we will look for 27 under 2, the difference of 1. So look for 27 here. So 27 under 2, this is 27. So under 2, this is 27 under 0, under 1, under 2, yes. So 27 under 2 is just this number here. That is 4, 3, 4, 6, yes. That's 27 under 2. Then difference of 1. So at the difference of 1, 27 under 2 is 2, 2, and the difference column is 2, 2. So therefore, when we add this, 27 under 2, as we've seen, is 4, 3, 4, 6. Yes, it's 4, 3, 4, 6. 27 under 2 is 4, 3, 4, 6. That is 4, 3, 4, 6. Difference of 2 is just 2, 2. So when we add it, we have 4, 3, 4, 8. So our answer for this question, log 272.1, is 2.4348. Okay, now we are on the next slide, finding anti-logarithms. So we are asked to find the anti-log of these numbers here. We are asked to find the anti-log. Now, how do we find the anti-log? There is a table for anti-log separately on the 4-figure table. So we have the anti-log here. It's written boldly on this. In your 4-figure table, you will see it written this way: anti-logarithm of numbers. So let's start with this number. I don't want to solve this first. Let me use a different number first to solve. So you are asked to find the anti-log of 0.2452. 2452. So how do we solve this problem? Now, this is anti-log, so I'll focus on my mantis this time around. I'll focus on my mantis this time around, focusing on, as you can see, the anti-log begins from 0.00. You can see clearly, begins from 0.00. Yes. So, how do we now solve this? Let's look for 0.24. So we'll look for 0.24 under 5 difference 2. Look for 0.24 under 5 difference 2. 0.24 under 5 difference 2. So this is 0.24 here. So this is 0.24. This is 0.24. So under 5. 0.24 under 5. This is under 0.24. Under 0, 1, 2, 3, 4, 5. Yes. 0.25 is just 1578. It's 1578. 1, 5, 1, 5, 7, 8. That's 0.24 under 5. Now difference of 2. Difference of 2.25 under 5 is 0.24 under 5 is 1758. Then difference of 2, this is 1, 2. Difference of 2 is just 1. Yes. So just as we've been doing, we're going to add it. So add it. And we have 8 plus 1, 9. We have 7. We have 5 and 1. So finally our answer is 1579. 1579. So we are not done yet. Now remember that the the whole number for this question is 0. Yes, while the decimal number is 0.2452. So on this whole number, whatsoever your whole number is for anti-log, you must add 1 to it. So our whole number here is 0 in this case. So I'm going to add this 1 to it. Don't forget that in log we subtract 1, but for anti-log is the reverse. We add 1. So I'll do plus 1 here, and 0 plus 1 is still 1. So in this case, I'll move my decimal 1 time forward. That is what it means. I'll move it 1 time forward. Yes. So my answer now becomes 1.579. If this question, let's see, if this question was actually, if you have to find the anti-logarithm, let me say 1.2452, I'll do the same thing. Yes, I'll do 0.24, which work, you found that before. 0.24 under 5 difference 1. That's 0.24 under 5 difference 1. 0.24 under 5 should be 1578, then plus 1 should be 1579. 1579. 1579. Yes. Now for this one, the whole number here is 1. And for logarithm we do a minus 1, but for anti-log we do the reverse, that is adding 1 to it. So on this one I have here, I will have, to add 1 to it, I will have 1 plus 1 equals to 2. That means I'll move forward 2 times. I'll move the decimal forward 2 times from the front. I'll go 1, 2, and then my answer becomes 15.79. Yes, that is it. And if also the question comes again this way, we had initially 0.2452. What about if it comes as 3.2452? You see, I just changed the whole number. Yes, the original question was 0, but I just used 3 here. What if it's now 3.2452? I'll still do the same thing. I'll look for 0.24 on the anti-log table. Look for 0.24 under 5. We've done that before. 0.24 under 5 difference of 2. It still give us 1. We still have 1579. That's the same thing. But you consider the whole number now. In logarithm we subtract 1. Yes, we subtract 1. But in this case for anti-log, whatever thing we have in our whole number, we add a 1 to it. For this question, our whole number is 3. So if I do 3 plus 1, yes, I will have 4. Exactly. So meaning that I'll move 4 times forward from the front. Meaning that we move 4 times forward. That is, I will have 1, 2, 3, and 4. Yes, so moving 4 times forward gives us this. And therefore, for this question, the anti-log of 3.242 is just 1579. Yes, and this is my answer here. Now let's solve from here. I'm going to solve just number 6 and number 7. So while you try the rest, I'm going to solve number 6 and 7. So, and then you try the rest numbers there. Now for number 6 and 7, the question is find the antilog of 4.0835. So how do we find this? It's just the same process. So finding the antilog of 4.0835. Now we look for 0.08 on the table. Let me zoom this a little so you can see it. From your antilog table, you look for 0.8 there. So something like this. Yeah, I think we have it here. So you look for 0.08. This is 0.08 here. 0.08. So we trace it. This 0.08 under 3 difference 5. 0.08 under 3. It's here. Yes. This 0.08 under 3. Now difference of 5. Difference of 5. This is difference of 1. Difference of 2, 3, 4, 5. Difference of 5 is just 1. So we've gotten our answer. 0.08 under 3, as we've seen, is just 1211. 0.08 under 3 is 1211. Now difference of 5 is still 1. So we have 1211 plus 1. That should be 1211. Yes. Plus 1. That should be 1212. So we have 1212. Now in this case, this is antilog, so be careful. We have 4 as the whole number. We have 4 as the whole number. So whenever you have for antilog the whole number, you always add 1 to it. Since we have 4 in the whole number, we're going to add a plus 1 to that 4. It becomes 5. So I'm going to move 5 decimal places forward from the left towards the right. So 5 decimal places forward like this. 1, 2, 3, 4, and 5. And then I stop. So what do you observe? That I can have a vacant space here. Yes, I can have a vacant space here. So I'll call here 0 since it is vacant. And therefore my answer becomes 1, 2, 1, 2, 0. So the antilog of 4.08 4.0835 is 12120. So we are at the 7th question. 5. The antilog of. So yes, find the antilog of 5.3019. 5.3019. So to find the antilog of 5.3019, so we do the same thing which we've been doing. So go to your antilog table. Look for 0.30 under 1 difference 9. This is 0.30 under 1. So this is 0.30. This is under 0. This is 0.30 under 1 here. Yes. 0.30 under 1. Difference of 9. There is difference of 1, difference of 2, difference of 3, difference of 4, difference of 5, difference of 6, 7, 8, 9. So difference of 9 is still 4. So 0.30 under 1 difference 9 is actually 2000. As you can see here, as we are saying, 2000 plus 4. It should give us 2004. Yes, we have 2004. Now, we're not done yet. Look at the whole number there. You know, in logarithm we do a minus 1, but for anti-log we do the reverse, that is we add 1. So we have 5 on the whole number, so we'll do a plus 1 to that 5 we are seeing there, and it becomes 6. Meaning that we'll move 6 decimal places forward from the left to the right. So we move 1, 2, 3, 4, 5, and 6. Yes. So there should be the vacant places here, so this should occupy 0 and 0 as well. So therefore our answer becomes 200400. So I think with these examples you can try the exercises here. You can try them out. Yes. I just saw my mistake. I wrote something in this I wrote find the logarithm of the following numbers. Please, it's supposed to be find the anti-logarithm. Yes, it's supposed to be find the anti-logarithm of this number, but not logarithm here, it's anti-log. So let's look at multiplication and division in logarithm. So when we are asked to multiply or divide in logarithms, so how can we go about it? So to multiply two or more numbers, we add their logarithm and thereafter find the anti-logarithm of the result. And as well, to divide two numbers, we subtract the logarithm of the divisor from the dividend and thereafter find the anti-logarithm of the result. So that we start right there. So now you have some few examples here where we are asked to multiply or evaluate the following using the logarithm table. We have some examples here. We are multiplying and also dividing. So from our example, we have the first question. Please evaluate 45.63 times 2.914. So to solve this problem, we set up the table this way. And then we have under the number column, we have 45.63 multiplying by 2.914. So first of all, let's determine the characteristics of these numbers. So as we know, 45.63, to get the characteristics, focus on the whole number. The whole number is just 45 here, and 45 has 2 digits. So to get the log value, we need first to get the characteristics. It becomes, since there are 2 digits in 45, I'll do 2 minus 1, and that is 1. Then points. Whenever you have the whole number, count the number of digits and subtract 1 from it. The same thing here for 2.914. 2 is the whole number here. 2 is the whole number. 0.914 is the decimal number. So the whole number here, 2, is just only 1 digit. Here, there's only 1 digit here, which is 2. So I will do a minus 1, and it becomes 0 point. Now the next thing to do is to check the logarithm value. So let's look for 45 under 6 equals 3. Let's look for 45 under 6 equals 3. So under the logarithm of numbers, look for 45. Look for 45, which we have here. So trace 45 under 6 difference of 3. So we have 45 is under 0, under 1, under 2, under 3, under 4, under 5, under 6. So 45 under 6 is 6590. 6590. Then difference of 3, difference of 1, 2, 3. Difference of 3 is just 3. And so let's add these values. So we get 45 under 6 difference 3 to be 6590. Now difference of 3, we got 3. So when I add these values, I'll have 3, 9, 5, 6 here. So my answer becomes 6, 5, 9, 3. And don't forget that in logarithm, whenever we multiply, we add the logarithm values. So let's look at the next one. Let's look for 29 under 1 difference 4. 29 under 1 difference 4. So 29 under 1 difference 4, as you can see, this is 29. This is under 0, under 1. Under 1 is 4639. Then difference of 4, 1, 2, 3, 4. Difference of 4 is 6. So 29 under 4 is 4. Sorry, 29 under 1 is 4, 6, 3, 9. So the difference of 4 is 6. So when we add this, we have 9 plus 6 is 15. We have other one, we have 4, 6, and 4. So it becomes 4, 6, 4, 5. Good. Now, finally, let's now add these values. So 3 plus 5 gives us 8. 9 plus 4 is 13. Write down 3. Keep 1 here. Now 1 plus 5 plus 6 gives us 12. Write 2. Carry 1. 1 plus 6 plus 4 is 11. So write down 1. Carry 1 again. 3 points. Then 1 plus 1 plus 0 is just 2. Now, having done this, to get our final answer, we need to get the antilog of this value. We need to get the antilog of 2.1238. So, we need to get the antilog of the final answer. So, let's go to our antilog table and look for 0.12 under 3. 0.12, that is 0.12 under 3 difference 8 in our antilog table. So at the antilog of numbers, let's look for 0.12 under 3 difference 8. 0.12 under 3 difference 8. So we have 0.12 is 0.12 under 3. This under 0, under 1, under 2. Yes, under 3 is 1327. Now difference of 8. 3, 6 is the difference below. Difference of 8 is difference of 1, 2, 3, 4, 5, 6, 7, 8. Difference of 8 gives us 2. So when we add these two values together, when we add this 1327, this is for 0.12 under 3, then because of 8 still give us 2. When we add it together, we have 9, 3 plus 2, 9. We have 2 here, 3 and 1. So finally, we have 1, 3, 2, 9. But we are not done yet. As we watched in the previous section of how to find anti-log of numbers, now look at the whole number here for this case. The whole number here is 2. The whole number here is 2. And for anti-log, in the whole number, always add 1. Just as in logarithm, we do minus 1. In anti-log, always do plus 1. Since I have 2 here now, I have 2 as a whole number. So I will do a plus 1. 2 plus 1 will give me 3. Therefore, I'll move my decimal 3 times forward. I'll move my decimal 3 times forward like this, from the front or from the left to the right. 3.4, I'll have 1, 2, and 3. And anywhere I stop, I'll put my decimal. And therefore, my answer becomes 132.9. And this happens to be our anti-log value. And that's the final answer. So you can do a check by pressing this on your calculator, by pressing the original question, 45.63 times 2.914. Although the answer will be an approximated value. Yes, the answer will be an approximated value. And it won't give you the exact thing on calculator, but to give you the very similar, but an approximated form of it. So we have the next question, 192.6 times 35.42 times 4.17. So we do the same setup this way. And before we solve, let's get here characteristics. Now for 190.6, the whole number here is 190. 190 is the whole number, and 190 has 3 digits. 190 has 3 digits. So we always do the 3 digits, or do the whole number minus 1 digit. So the whole number 190 has 1, 9, and 2. So do a minus 1 and those 3 digits. I will have 2. And the next number, 35, 35.42. 35 is the whole number, and 35 contains only 2 digits. Do a minus 1 and those 2 digits. I will have just 1 left. And 4.1. 4 is the only, 4 is a whole number here, and it is just the only, it has just only 1 digit. Yes, so 4 is the whole number here, and it contains only 1 digit. So do a minus 1. I have 1 minus 1, that is 0. Point. Now let's get the logarithm of this number. Let's get the logarithms. Let's look for the first one. Look for 19 under 2 equals 6. So looking for 19 under 2 equals 6 under the logarithm of numbers on the table. So look for 19 under 2 differences. Also do the same thing for every other number, and we have that 19 under 2 differences. It's after getting everything and adding, we have 2, 8, 4, 6. Now also for the next one, look for 35 under 4 difference 2. 35 under 4 difference 2. Under the logarithm of number 35 under 4 then you get the difference of 2. You add everything. So after doing that, which I believe you can now do, we have our answer to be 5, 4, 9, 2. And for the last one, we have just, we can't find just 4. We don't have logarithm of 4 on the table. Logarithm begins from 10. So we cannot find 4 here. Let's say find 41 only. Find 41 and just under 0. No difference here. So it's for 41. Still on your logarithm table, it's for 41. So clearly, as you can see, 41 under 0 is just 6128. It's just 6128. So you write it down here. It's 6128. So you're multiplying here. Therefore, it means you add everything here. So when you add everything here, this way, let's see the answer after adding. So after adding, we have our answer to be 4.4466. We have 4.4466. I believe you can add. Now at this juncture, let's now find the anti-logarithm. The anti-log of 0.44 under 6 difference 6. 0.44 under 6 differences. And once you're done, since we have our whole number to be 4 here, I'll add an extra 1 to it, so it becomes 5, and I'll move 5 times forward on the right. So at the anti-log table with 4.44 under 6 difference 6 and 44 under 6 difference 8. So as you can see that when you look for it, 44 under 6 differences, then you check your answer down there. So after adding 0.44 under 6 differences, after adding it gives us 2. So having gotten our anti-log value as 2797, we are not yet done. Just make one more step. Like I said, focus on the whole number here. The whole number here is 4. And since we are treating anti-log, I will always add a 1 to my whole number. So if I add 1 to 4, it becomes 5. And then the final answer becomes let's do somewhere else. Yeah, I'll have 2, 7, 9, 7, yes, 2797. And since our whole number here is 4, I'm going to move, I'll add an extra 1 to the 4 to become 5, like I said, and I'll move 5 times forward. So, moving 5 times forward from the left to the right, I'll have 1, 2, 3, 4, and then 5. So, what you observe now, we have a vacant space here, so you can put here as 0. Yes, if I have such vacant space, I can just put 0 there. So, and this is why I'll have 0 behind here. Yes, and this gives the final answer to the question we have. So this is the anti-log value in this. Now we have the next example 2, where we are dividing two numbers using the logarithm table. Now we do our usual setup, which is like this. Now let's look at the numbers here. The whole number here is just 634, so it has 3 digits. So 3 minus 1 3 digits minus 1 gives us 2 digits left. Here we have 26.94. 26 is the whole number and it has 2 digits. 2 digits minus 1 is just 1. I will have 1 here and 1 here. Now the next thing, we are treating logarithm. So we go to the logarithm table and look for 63 under 4 difference of 7. 63 under 4 difference of 7. So as you can see on our log table, 63 under 4 difference of 7 is 8026. That is 8026. And so also let's look for 26 under 9 difference 4. 26 under 9 difference 4. So 26 under 9 difference 4, after checking, it's 4. This, once you get it, you add difference. Once you get 26 under 9, whatever thing you have, look for the difference of 4. Whatever thing you have in the difference, you add it. So we have it to be 4, 3, 4, 3, 0, 5. 4, 3, 0, 5. So in this case, since we are dividing, we subtract. Yes, we subtract. So 5 here is 1. 2 minus 0 is 2. 0 minus 3 can't go to 1 from here. And add here becomes 10. 10 minus 3 is 7. I have 7 left here. Minus 4 is 3. Then 2 minus 1 is 2. Good. So we now have our answer after we subtracted the log values. Now let's find the antilog. We find the antilog of 0.37 now. 0.37 under 2 difference 1. 0.37 under 2 difference 1. So under the antilog of numbers, let's look for 0.37 under 2 difference 1. 0.37 under 2. So as you can see it, 0.37 under 2 is 2355. Then difference of 1, the difference of 1 is 21. So when you add these two values, it gives us 2356. So we will have here 2356. And then as we know, look at the whole number here is 1. For antilog, to get the antilog, we always add an extra 1 to our whole number. So the whole number here is 1. So if I add an extra 1 to the whole number, it becomes 2. So I'll move my decimal 2 times forward. And I'll have movement 1 time and 2 times. And then anywhere you stop, you put your decimal. So therefore, our answer becomes 23.56. This gives us the value of our anti-logarithm as 23.56. Now let's look at the next slide here. We have powers and roots. Powers and roots. So whenever we're given the power here, like I said, in the context of logarithms, whenever we have a number raised to any power, any number at all carrying the power, just multiply the logarithm of that number that the power is carrying. If it's carrying the power of 2, multiply by 2. If power of 5 multiplied by 5, if it has the power of 1 over 2 multiplied by 1 over 2, just whatsoever power is carrying, multiply the log value by that power. Also for root, in the context of logarithms also, whenever we have a number under a root sign, if it's having a root sign, just divide the logarithm of that number by the given root. Just divide it. If it's having a square root, divide by 2. If it's having a cube root, divide by 3. If it's having a fourth root, divide by 4. Whatsoever power is carrying, whatsoever root it is having, divide by that root. Or perhaps you can change the given root to power by the law of indices. You can change a given root to power and then multiply. So we have some questions here. We are asked to evaluate the following using logarithms. So let's see how this can be done. So from the question here, as we have a setup. So 24.7 squared. So just do the usual thing here. The whole number here is 24 and it has only one digit. So and it has two digits. 24 has two digits, 2 and 4. So always do a minus 1 on that whole number. So the 2 digit minus 1, I'll have 1 left. And then point. We now look for 24 under 7. We look for 24 under 7. So 24 under 7, this is 24 under 0, under 1, 2, 3, 4, 5, 6, 7. 24 under 7 is 3927. So it's 3927. We have 3927. Yes, and as we said, whenever we have the power, we always do what? Multiply. We always multiply. Yes, in the context of logarithm, whenever a number is raised to any power, just multiply, and we have this to be, this is a square, this is the power of 2, so multiply by 2, and whatsoever answer you get, you write it somewhere. So on your calculator, when you press 1.3927 times 2, it gives us 2.7854. Yes, so we are not done yet. Just one more step. Let's look for the antilog of 0.78 under 5 difference 4. 0.78 under 5 difference 4. So at the anti-logarithm table, 0.78 under 5 difference 4. So let's look for it. 0.78 under 5. It's 1, 2, 3, 4. That is 6081. Okay, sorry, it should be 6095. 0.78 under 5 is 6095. Difference of 4. Difference of 4 from 6. So when you add these values, you have you have 6101. Yes, 6101. 0.78 under 5 difference 4. The antilog is 6101. So Notice that our whole number here is 2, the whole number here is 2, and for the anti-log, we always add a 1 to the whole number. So adding a 1 to 2 makes it 3. So I'll move 3 times forward. I'll move 3 times forward from the left to the right. So I'll have 1, 2, and 3. Anywhere I still put my decimal. And my answer becomes 610.1. And this is the anti-logarithm for this answer here. So we have the next question here. Evaluate using logarithm 1.91 to the power of 3. So how do we solve it? It's just the same process also. We have the setup. Now the whole number here is just only 1. That is, there is only 1 digit here. Yes, there is only 1 digit here. So I will do minus 1. So 1 digit minus 1 should give us 0 and then point. Then we look for 19 under 4 difference 1. So under the log table, 19 under 1, 19 under 4 difference 1 under 4 is 2878. Then difference of 1 is 2. So when you add 2878 plus 2, you have 2880. So here we have 2880. And you could notice that we have a power of 3 here. So for powers, multiply by 3, and using the calculator you get the actual value. So we have 0.864, and the calculator, when you point this value, you have 0.864. So next thing is to find the anti-log of this number, the anti-log of 0.86 under 4. 0.86 under 4 using the anti-log table. So 0.86 under 4, this is under the logarithm table. 0.86 under 4, it's 8.86 under 0, 1, 2, 3, 4. Yes, 7311. So 0.86 under 4 is 7311. And so once you're done with that, now look at the whole number here. The whole number is 0 here. So as we always know, for anti-log, in our whole number, we always add an extra 1 to the whole number. So I will have, my whole number here is 0. So when I add an extra 1 to 0, I will have 1. So meaning that I will move my decimal 1 time forward from the left towards the right. From the left, move 1 time, like this, 1. So anywhere you stop, you put your decimal. If you move 1 from here to here, you stop and put your decimal. So this becomes 7.311, and this happens to be the value of our anti-logarithm for this. So over to the next question. 216 raised to the power of 1 over 3. 216 raised to the power of 1 over 3. Now let's have our setup this way. Yes, 216 raised to the power of 1 over 3. So first of all, the number here we are given is 216 carrying a power of 1 over 3. Now the whole number is just a whole number, no decimal on this number. 216 is just alone here, it has no decimal. So, and as we know, for the whole number, count the number of digits in the whole number and do a minus 1. 216 has 3 digits only, 2, 1 and 6. So do a minus 1 on this number of digits. 3 digits minus 1 gives us 2 digits left, points. And then we look for 21 just under 6. Look for the logarithm of 21 under 6 only. So 21 under 6, as you can see from the table, 21 under 6, this is under 0, 1, 2, 3, 4, 5, 6. It's 3, 3, 4, 5. 3, 3, 4, 5. So write it down here. That's 3, 3, 4, 5. Yes. Now having done this, the next thing to do is we are having a power here, and for power we know that we always multiply by the power. So the power here is 1 over 3, so I will have times 1 over 3. So let's get our answer. So 2.3345 times 1 over 3 gives us what? So on the calculator, this gave us a very long number. So but for the fact that we are dealing with 4 figures, let's just round it up to 4 decimal places. And we have 0.778. So to the 4th decimal place, I will have to, yes, I have to approximate to 4 decimal places. So this is what we'll be having here. And then we now look for the antilog of 0.77 under 8 difference 2. Antilog of 0.77 under 8 difference 2. So under the antilog of numbers 0.77 under 8 difference 2, 0.77 under 8 is 5998. Difference of 2 is just 3. So when you add these values here, you have 6001. So 5998 plus 3 is 6001. So we have 6001 here. Now we are not done. The last step is look at our last point here before we found the antilog, because we need to find the antilog of 0.7782. So we found that of 0.7782. Then for the whole number there, the whole number is 0, and as we know, for our whole number in antilog, we always add an extra 1. So adding 1 to 0, 0 plus 1 is still 1. So meaning that I'll move my decimal 1 time forward from the left to the right. So from the left, I'll move 1 time forward. I'll move 1 time forward, 1, and I'll stop. So finally, my answer is 6.001, which this happens to be our antilog value for this. And we have the next example when it involves roots. So we have 467. The square root of 467.5. Okay, so let's see how it goes. So this is how I will have my setup, like this. So, and we proceed. Now let's look at the whole number in here. This is 467. So we need to look for 46 under 7 difference 5 under the log table. 46 under 7 difference 5. So 46 under 7 difference 5 is 6693. then difference of 5 is still 5. So when you add these values, you have 6698. So we have 6698. But before that, I need something. You do not get this characteristics here. Yes, 467.5. The whole number is 467. It has 3 digits. So 3 minus 1 and those 3 digits. 3 digits minus 1 is just 2.5 points. And then what I just found now, 46 under 70.5. I should be 6, 6, 9, 8. Now, this is a square root. Yes, a square root. So meaning that we divide by 2. Yes, we divide by 2 since it's a square root. If it were to be a cube root, I'll divide by 3. So let's now divide. For root sign, don't forget you divide. For powers, you multiply. So 2.6698 divided by 2 will give us 1.3 1.3349. So we have 1.3349. So therefore, let's now get the antilog of this number. Let's get the antilog of this number. So find the antilog of 0.33 under 4 difference 9. 0.33 under 4 difference 9. Antilog of 0.33 under 4 difference 9. So from table, 0.33 under 4 difference 9, as we have here, is 2158, difference 9 is 4, so when you add, you have 2162. So we have 2162, so 2162. So one more step. This number which we just found the antilog, the whole number here is actually 1. The whole number here is 1. And for antilog, when you have on your whole number, always add an extra 1 to it. Always add an extra 1 to it. It gives us 2. So 1 plus 1 here is just 2. So meaning that I would move 2 times forward. 2 times forward. Sorry, this number needs to be here. So moving 2 times forward from the left to the right, I'll have 1 and 2. So anywhere you stop, you put a decimal point. And so my final answer to this question becomes 21.62. So, and this is our anti-log value for this. So for the next question, we have the 4th root of 12.5. The 4th root of 12.5. So how do we solve this here? Now 12.5 is a decimal number, and check the whole number. It has just 2 digits in the whole number. 2 digits are in the whole number, that is 1 and 2. So always 3 minus 1. Now we have 2 digits minus 1 is just 1, and then point. Now we look for 12 under 5 only. 12 under 5 only. So under logarithm, 12 under 5 is under 12 under 0, 1, 2, 3, 4, 5. 0969. 0969. So we write it here. 0969. Since this is a root, the 4th root, we divide by 4. Yes, and our answer becomes 1.0969 divided by 4 So it gave us a long number, but not too long. So we approximate to 4 decimal places. We have 0.274. Yes. The next number after this is not 5, so I'll round down. So I'm going to have 0.2742. Now, let's now find the antilog of 0.2742. First of all, we start by finding 0.27 under 4 difference 2 under antilog. 0.27 under 4 difference of 2 in the antilog table. 0.27 under 4, as you can see, for antilog table, 0.27 under 4 is 1879, and difference of 2 is just 1. So when we add it, it gives us 1880. So we write it here. It becomes 1880. So the whole number here is just 0, as you can see. For this part here, the whole number is just 0. So we always do a plus 1 to that. So when we do 0 plus 1, it gives us 1. So meaning that we will move 1 decimal place forward from the left towards the right. So we'll move 1 decimal place forward and move 1 time. And then anywhere I stop, I'll put my decimal. So finally, my answer becomes 1.880, which since 0 under the decimal, my final answer should be 1.88. So, because whenever 0 ends the decimal, it's good at taking it away. So I have my antilog. So this is my antilog. 1.88. So having solved this problem, let's look at the next thing here. Let's look at cases where, let's see where we could be asked when we could be given mixed calculations on this. So let's try these examples when there are mixed calculation, when there are multiplication, division, roots, and powers all at the same time. So let's see how we can tackle this problem. So let's attempt them one by one. And for the first one, we have 29.86 times 105.2 all over 285.3. So we have our setup this way. The number here and log sum of it. Now, for the numerator, we have 29.86 multiplying with 105.2. Now, as we know, it's just the same process. So let's get the characteristics of this number. This is 29.86. It has just 2 digits in the decimal. So do a minus 1. I have 1 point. So I will now find 29 under 8 difference 6. So let's find 29 under 8 difference 6. So when we take that, 29 under 8 difference 6 in logarithm, is after adding everything, we will have 4751. So we have 4751, 4751 And also for the next number 105.2, the whole number is 105, so it has 3 digits. So do a minus 1 and I'll have 2 points. Then we find 10 under 5 difference 2 from log table. 10 under 5 is 0212, difference 2 is 8. And when you add these two values, you have 0220. So we have 0 0220. So now don't forget that we are multiplying. So in that case, since we are multiplying, that means we will add. We will add our values. We will add the logarithm values. And this gives us, when we add this, we have 34971. Yes, we have 34971, and this value is for our numerator. It's for the numerator only. So now let's roll it out. And then, as for the denominator, what do we have there? So we have 685.3. Yes, as for our denominator. To do the same thing, let's look for the characteristics, which is 6. That is, the whole number here is 685. It has 3 digits. So do a minus 1. I will have 2 points. Now let's find 68 under 5 difference of 3. 68 under 5 difference 3. So when you check that, 68 under 5 difference 3, 68 under 5, as you can see, is 8357, difference of 3 is 2. So when you add both values, you have 8359. So I'm going to have 8359. So, and this value here is for our denominator. So as you can see, this value here is for our denominator. As you can see. So now don't forget, look at the question. They said let the numerator be divided by the denominator. So meaning that we need to do a subtraction here. Let's draw an extra column here. So as you can see now, this is my value of the numerator, which says 3.4971. So since we are dividing numerator by denominator, means I subtract minus. The denominator is 2.8359. So these are the values of the log. So let's now subtract it. So when you subtract 3.4971 minus 2.8359, so it gives us 201.66, then 0. Yeah. So when we do this, we'll be having 0.6612. So having done all these things, the final thing to do is to get the anti-logarithm. So how do we get the anti-log? We look for 0.66 under 1 difference 2. 0.66 under 1 difference 2. So from the anti-log table, 0.66 under 1 is 4581. Then difference of 2 is also 2. So when we add these values, we have our answer to be 4583. Yes, we have 4583 here. So 4583. Now consider this number, the whole number here. The whole number here is 0. So the whole number here is 0. So, and for anti-log, we always add a +1 to our whole numbers. So 0 plus 1 is 1, meaning that I'll move forward one time. Anywhere I stop, I put my decimal. So therefore, the final answer to this problem is 4.583. So this is the value of our anti-log, 4.583. That is the final answer. So here we have the next question, number 2. So let's now set it up this way. So I'll have 455.62. So, but observe something here. If I'm to get my characteristics here, I have 3 digits here, so I'll do a -1. It becomes 2. That is how it's being done. Always do a -1 on the number of digits in the whole number. Now, but notice here that if I check on log table, 45 under 5 becomes 6. What about this 2 here? This 2 is left out. So, without wasting time, the best thing to do is to approximate it. The 2 here is not up to 5, it's less than 5, so I will round down. I will round it down, meaning that I'm going to use just 45.6 only. Okay, and so we now have it. So let's now find 45 under 5 difference of 6. Let's now find 45 under 5 difference 6. So, but before that, let me write something here for you so you can see it clearly. We have the original number for 455.62, which we approximated to 455.6. Yes, because had even 2 was up to 5, I would have taken 1 from 2 and add to 6, it becomes 7. But it is not up to. So let's now find 45 under 5 difference 6. So from the table we have here, our 4-figure table for logarithm. So 45 under 5 difference 6. 45 under 5 difference 6 is 6580. Difference of 6 is still 6. So when you add both values, it gives us 6586. So we write it down here as 0.6586. Now we go to the next number in the numerator, that is 331. So 331.88. Don't forget that you're multiplying them. Now the same thing also happened here. If I get my characteristics, there are 3 digits here, 3, 3 and 1, 3 digits. So 3 minus 1, I'll have 2 point something. So if I try to find 33 under 1 difference 8, what about this 8 here is left out? So whenever I have such case, when 1 digit is left out, just do an approximation from the end. So I will have that 331.88 is approximately, so I will do it today. I will have to approximate to 1 decimal place. So 1, 2, 3, 2 becomes 331 point. So the number left out is 8 and it's up to 5. So if I take 1 and add to the other 8 beside it, it becomes 9. Yes. So if had even it was not up to 8, had it been this last digit here, the decimal, was not up to 5, just like we had in the previous one, 455.62. so I wouldn't have done anything here. But since it's up to 5 and above, I will take a 1 from the 8 and add there, and it becomes 9. So now my question should change slightly, my numbers here. So I wouldn't call it again 88, I will just call it 331.9. And then we're going to look for 33 under 1 difference 9. 33 under 1 difference 9, since it has been approximated. 33 under 1 difference 9. From the log table here we have 33 under 1 difference 9 is 5198. 5198 under 1. Then difference of 9 is 12. So when you add 5198 with 12, you're going to have 5210. So you have 5210. So we are still at the numerator, and don't forget that we are adding there. We are adding. So let's now add the values in our numerator. So 6 plus 0 is 2, 6 is 9, this is 7, 11 here, take 1, and here becomes 5. So after addition, you see that our numerator is now, so what I have here is my numerator. The numerator is now 5.1796. That's for the numerator. Now let's now get the values in the denominator. Let's now get the value in the denominator. So as for the denominator, we have 31.5. Sorry, we have 315.6 multiplying 95.47. So do the same thing here. Our characteristics here is there are 3 digits in the whole number. That is 3, 1, and 5. 315. That is the whole number. So since there are 3 digits, we do a minus 1. So now let's now get 31 under 5 difference 6. 31 under 5 difference 6. So from the log table, 31 under 5 difference 6. 31 under 5. 1, 2, 3, 4, 5. Yes, 31 under 5 difference 6 is 4983. Now difference of 6 is 8. So when you add these values, you have 4991. So we're going to have 4991. Also for here, 95.47, the whole number is 95. It has 2 digits. So as we know, we will always do a minus 1. So 2 digits minus 1 still leave us with 1. Now we will now find 95 under 4 difference 7. 95 under 4 difference of 7. 95 under 4 difference 7. Under the log table, 95 under 4, 95 under 4, 95 under 4 is 9795. Difference of 7 is 3. So when you add these values, you have 9798. You have 9798. So we have 9798. Yes. So in the denominator we are multiplying as well. So meaning that we are going to add. We are going to add. So now an addition, what is our answer? Now we have 1 plus is 9, this is 18, have 7 here. I have 14.4. Okay, so we have 4.4789. Okay, now we are done with the numerator and the denominator. So this is the denominator. Yes, so we've gotten it. Now the last thing we need to do here is to we are dividing the numerator by the denominator. Yes, we are dividing the numerator by the denominator. So let's create another column here. So we have okay, so by doing this way, we have for our numerator we have 5.1796, and also for the denominator we have 4.4789. So since we are dividing in this case now the numerator by denominator, let's now subtract it, because that is the law of logarithm. When you're dividing, you subtract. So now on subtracting these figures, we end up having 7 0 0 0 7 0. Yes, so we have 0.7007. Now we're done. Let's now get the anti-logarithm. The anti-log of 0.70 under 0 equals 7. 0.70 under 0 equals 7. So 0.70, as we see here, under anti-log, 0.70 under 0 is 5012. Now difference of 7 is 8. So when you add 5012 plus 8, you end up having 5020. So you end up having 5020. So here we have 5020. Now, and after that, since we are finding the anti-log, don't forget that the whole number here is 0. Yes, whatever thing you have in your whole number in anti-log, always add a 1 to it. So when you have 0 plus 1, it becomes plus 1. Yes. If there was a 2 here on this, at this 0 position, if there was a 2 there, I will do a 2 plus the 1, that is the rule, which gives me equals to 3, and I'll move 3 decimal places forward. But in this case we have 0 there, so it means I'm going to move, if I add 1, that is the rule, to the 0, it gives me 1, so 0 plus 1 is 1, and then I move 1 decimal place forward, from the left towards the right. So from the left towards the right, I will have this. And then the final answer becomes 5.020. So this is actually the anti-log giving us the answer. So that is our answer, 5.020, which you can still write as 1. Since 0 is the last thing here, ending this decimal number, you can still have it as 5.02. That's my final answer. Now let's look at the third question here. The third question. So we have 17.2 all squared times what you're seeing there. So let's now do our setup. Start by writing the number and the logarithm form of these numbers. So let's start with the numerator. We have 17 and 2 17.2 so all squared, and then we have 4.93. So we are multiplying here. Now, how do we do this? As you know, in power, for power we multiply by the power. Now 17 here, 17 is a whole number here, so it's having 2 digits. So I'll do a -1 and I'll have 1 point. Now we look for 17 under 2. We look for 17 under 2. And so 17 under 2 is just 2355, as you can see under logarithm. 17 under 2 is 2355. So we write it down here as 2355. And now, since we are having a power there, we multiply by 2. Yes, since we have power of 2, multiply by 2. And this gives us multiplying by 2 on your calculator, you have 2.471. You have 2.471. Yes. And now for the next number here, the whole number here is 4. There's only 1 digit in the whole number. Do a -1, I will have 0. Right? And then we find 49 under 3 in logarithm. So 49 under 3 is 6928. 49 under 3 is 6928. So we write it down here as 6928. That's 6928. And now don't forget that we are multiplying here. So remember that we add these values we just got now. We add these values we just gotten. So therefore, let me do it here. The values I have, like the first one, I have 2.471. So if you add it, since we are multiplying, we add 0.6928. So we can call here 0 since nothing is there. So when we add this, we have 3 points. That is, okay, I will have 8 here, 3, I will have 16, okay, 16 here, everyone will have 11, right. So we have 3.1638, 3.1638. So that is for the numerator. So let's write it somewhere here. This is for the numerator. So let's get that of the denominator. So, and for the denominator, what do we have here? We have the cube root. We have the cube root of 675,000. 675,000. Now, this number inside here, check how many digits, or it is a whole number, it's not a decimal number, so it's all whole numbers. So count the whole numbers here. You have 1, 2, 3, 4, 5, 6, 7. So there are 7 whole numbers here. So I will do a minus 1 and I will have 6 points. Now we'll look for 67 under 5. So look for 67 under 5. We don't have the point 0, so no need. Just use only 67 under 5. So as you can see, 67 under 5, 1, 2, 3, 4, 5 is 8293. It's 8293. That is 8293. Now it's a cube root. It's a root. So for roots we divide. So since this is cube root, I divide by 3. I'll divide by 3, and we have our answer. When you divide by 3, dividing this by 3 gives us 2.2764. So 2.2764. Yes. So we've gotten the value for our denominator. So this, everything here happens to be our denominator. This is our denominator. Yes. So we've gotten the values of the numerator, that is the log values, and gotten the log values also for the denominator. So one more step. Since we are asked to divide numerator by denominator, let's now divide these values of their logarithm. So this way. Okay, so we have let's bring it out. This is for numerator, and this is for denominator as here. So let's evaluate them. We have 3.1638. So since we are dividing numerator by denominator, we subtract minus 2.27. 2.2764. So, and that will give us 0.8874. When you subtract it the calculator or by hand, we have 0.8874. So we've done the major things. Now let's now get the anti-log. So to get the anti-log of this, we need to do the anti-log of 0.88 under 7 difference 4. 0.88 under 7 difference 4. So for anti-log 0.88 under 7 difference 4. 0.88 under 7 difference 4. 0.88 under 7 is 7709. Difference 4 is still 7. So when you add this, when you add 7709 plus 7, we have 7716. So we have 7716. So we have 7716. So I think, and then for the last step, here the whole number here for this value we try getting the anti-log. The whole number here is 0, and like I said, for anti-log, the whole number always add a plus 1. So when I add 1 to this 0 here, it becomes 1. So meaning that I'll move 1 decimal place forward from the left towards the right. So I'll move 1 decimal place forward like this, and then pick my decimal. So finally my answer becomes 7.716. and this is the value of our anti-log. Yes, so 7.7716 is the final answer to that problem using the logarithm table. So let's look at the fourth question. The fourth question says the cube root of 10900 times 392.8 all squared divided by 39.436 times 1203 squared. So how can we tackle this problem? It looks quite complicated, but let's do justice to that little by little. So let's start with the numerator, with the inside. So from the inside we have 1,0,0900. So multiply 392.8 squared. So now let's begin. As we know, we need to get our characteristics of this number. So this 10900 is just a whole number. So we need to get the characteristics, which is, you must know the number of digits in the whole number. So 10900 has 1, 2, 3, 4, 5 digits. So do it 5 minus 1, and you have 4 point something, and you have 4 point something there. So let's look at the next number here. The next number here we have is 392.8, and the whole number here is just 392. So it has 3 digits. So we just do a minus 1 there. 3 digits minus 1 will leave us with 2 digits, and we have 2 points something there. So let's get their logarithm values one after the other. So beginning with the first one, we will do 10 under 9. Yes, just 10 under 9, and that's all. We don't have different 0. So just do 10 under 9 only. So as you can see, 10 under 9 is just 0374. 0374. So we have here as 0374. Now for the next number, we will find 39 under 2 difference 8. 39 under 2 difference of 8. So 39 under 2 difference 8 is 5933. So difference of 8 should be 9. So when you add that value, you have 5942. So here we have 5, 9, 4, and 2. Now since we are multiplying, it means we add their logarithm value, and then we have it will be, so adding here we have 4 plus 2, we have 6, which is 6, 11, 13, we have 6.6. So, oh sorry, I'm not yet done. Sorry, that was a mistake here. Sorry about that. So, having gotten this value, before you add, don't forget that there is a square on this number here. There is a square here. So, and as you know, for powers, you multiply by 2. Yes, multiply by 2. So multiplying by 2, we have our answer to be, so on calculator, 2.5942 times 2 to give us 5.1884. 1.5.1884. So therefore we will now add these two values here. Therefore we add the log value for 10900, which is 4.0374, then plus this log value we just had now, which is 5.1884. So let's add them together, and we have it to be 8, it should be 5, 2.9. So, and this happens to be for our numerator. This value happens to be for our numerator. The numerator. So let's now go over to the denominator. Now, to the denominator, we have some values there. We have 39.436 and 12.03 all squared. So now for this one here, the number here, what is the characteristics of the number here? The whole number here is 39. That is just two digits, 3 and 9. So we do a minus 1. We have 1 point something. Now, and then we find 39 under 4 difference 3. So we have a small problem here. 39 under 4 difference 3. What about this 6 here? It is left out. So in that case, as we've had such experience, we approximate. So this 6 here is up to 5. If I take 1 and add to this 3, it becomes 4. So we'll be having 39.44. Yes. And so it becomes 39.44. Then we now find 39 under 4 difference 4. 39 under 4 difference 4. So from the log table, 39 under 4 difference 4 is 5955. Difference of 4 is still 4. So when you add both values, you end up having 5959. Yes. And so for the next number, 12.03, 12 is the whole number here, so we have just two digits, 1 and 2. So do minus 1, I will have 1 point. And now we look for 12 under 0 difference 3. Look for 12 under 0 difference 3. So 12 under 0 difference 3 is 0792. Difference of 3 happens to be 10. So when you add these values, you end up having 0802. So we have here as 0802. Now don't forget that we have the power here, and for powers, as we know, we multiply by the corresponding power, so that is times 2. It is equal to, so multiplying 1.0802 by 2, we have 1 point, sorry, not 1 point, then I have 2.1604. Yes, 1.802 times 2 is 2.1604. And so therefore, this is the value for our, okay, we are not yet done, sorry. We need to, since we are multiplying here in the denominator, yes, we are multiplying there, so we need to add the values there. So therefore, let's now add our values. Let's now add them. the value for 39.44, the left value is 1.5959, and that of 12.03 all squared is 2.1604. So when I add these two answers, when you add them, our answer becomes so we have 3.7563. We have 3.7563. So this is the value for our denominator. Denominator. Yes. So that is the value for our denominator. Okay. So we are almost done with this. But don't forget that we are asked to divide the numerator by the denominator from our question. We are asked to divide the numerator by the denominator. Just as we have here. We are asked to divide the numerator by the denominator. So let's now divide before we take all the cube roots. Let's now divide before taking all the cube roots. So we go this way. To divide, meaning that we need to do some subtractions. So let's draw from here. Now, for this numerator, we have 9.2258, and for the denominator, we've done every simplification and evaluation. We have 3.7563. So when you subtract these values, since we are dividing everything, so when you subtract these values, you get 5.46. Get 5.4695. And this value was gotten when we divided the numerator. When we divided the numerator divided by the denominator. That was what gave us this value after all our simplification. So let's now take the main one. So after doing this fraction in here, we will now need to take all the cube roots. So we'll have something like this in here, So taking all the cube roots. Now don't forget that we've evaluated this inner fraction. We've done 10900 and 392.8 squared divided. We've done everything there, and that was what gave us 5.4695. Now since we are taking the cube roots, it is a root and the cube at the cube root, so we'll have divided by 3. So we'll have to divide by 3. So dividing on the calculator, 5.4695 divided by 3. So that's it's a very long decimal. So since we are using 4 figures, we have to approximate it. So we're going to have it to be equal to 1.823 and 2. Yes. So I did it to 4 decimal places. So it becomes 1.8232. So that's, we've gotten everything we need to have. And one more last thing again. Let's now take the anti-logarithm. the antilog. So let's find the antilog of 0.82 under 3 difference 2. 0.82 under 3 difference 2. So from antilog table, 0.82 under 3 difference 2. 0.83 under 2. Sorry, 0.82 under 3. 0.82 under 3 is 6653. 0.82 under 3, 6653. Now difference of 2 is still 3. So when you add these both values, it gives us 6656. So we're going to have 6656. Sorry, that should be written by on the left hand side. So notice that the whole number here is 1, and as we know, on our whole number, we always add an extra 1 to it. Always add an extra 1 to your whole number. So since we have 1 here, when I add an extra 1, it becomes 2. So it then means that I'll move 2 decimal places forward from the left. I'll move 2 decimal places forward. This 1, 2. And anywhere you stop, you put your decimal. And so my answer becomes 66.56. Although from the question we are asked to round up to correct to 2 significant figures. So of course, for this question, 6 is the first significant figure, 6 also is the second here, 5 is the third, and 6 is the fourth. So we are asked to approximate to 2 significant figures, and as you can see, the second figure that is significant here is 6. So 6. What is next to this 6 is 5. So if I take 1 from here and add here, it becomes 67. So our final answer becomes approximately 67 to 2 significant figures. I believe you should know how to approximate at this stage. So this is our anti-lock value. 67 to 2 significant figure. So thank you for watching this. So ask your questions where necessary.